18B part 2. We'll do some sums which were cancelled in the previous video. Let's start with question 5. Question 6 will be for homework. Draw the diagram on your own. Here's the diagram. Whatever is in red is not given, that we'll find in the course of solving the sum. We have to prove that BD is equal to BC. The strategy would be to prove BCD is an isosceles triangle. If I can prove that this small angle and this small angle are equal, then we can prove BC equal to BD by isosceles triangle theorem. The only angle given is this one, 30. Well, if this is 30, then this central angle will be 60. So this is a construction, OC. So mention that. Now, in triangle ACB, angle ACB is 90 degrees because it is angle subtended by the diameter on the circle. And if this is 30 and this is 90, then angle OBC is 60, angle sum property of the triangle. Next, in triangle OCD, angle OCD is also 90 degrees because radius is perpendicular to the tangent. And this is 60. So again, angle sum property, this is 30. Next, angle OBC is an exterior angle for triangle CBD. So it will be equal to the sum of the interior angles, that is angle C and angle D. So if this is 60 and this is 30, automatically this is 30. And once we prove that these two angles are equal, it follows that BC equal to BD, isosceles triangle theorem. So here are the steps. The reasons, right? All the reasons. Next, let's go for the 7th sum. The diagram is already given. We have to prove that OA bisects angle BAC. That means I have to prove that angle CAO is equal to OAB, this one. That's what I have to prove. Angle CAO is equal to angle OBA, angles in alternate segments. Notice how both these angles are cutting the same arc OA. See, you should be able to visualize that a particular arc is being cut by which two angles. That is a major part of solving these sums. Next, in triangle OBA, OA and OB are radii of the same circle, that is a small circle. So it's an isosceles triangle property. This angle is equal to this. Hence prove that this is equal to this and this is the angle bisector. Here are the steps. Next we move on to the 9th sum. By the way, the 8th sum will be for homework. Note the markings I have done. Here the diagram is like this. We have to prove that DS is parallel to DB. So what is given is that this is equal to this. But this is equal to this, angles in the same segment cutting the same arc DA. And this is equal to this, again angles in the same segment cutting the arc AB. And this angle is equal to this angle. Angles in alternate angles, this and this, they cut the same arc AB. So that means ultimately this angle is equal to this angle. And they are alternate angles. And if alternate angles are equal, then this is parallel to this. Here are the statements. Next, let's go for the 12th sum. By the way, the 11th sum is for homework. Now in the 12th sum, the diagram is again given. There are two parts. First, they've asked us to prove that triangle PAD is an isosceles triangle. So let's do that first. PAD is isosceles. So let's assume that PAB is X. That means angle ACD is also x, angles in the alternate segments cutting the same arc AB. Also, let angle BAD be y and DAC also y. That is given that they are equal. It's given. So now angle PAD entirely is x plus y. Also, angle ADP is an exterior angle for triangle DAC. So it will be equal to the sum of the interior angle, that is again this is x plus y. So in triangle PDA, I just proved that the base angles PDA and PAT both are x plus y, hence proved that it is an isosceles triangle. Next, we have to prove this. So again, we'll use XY method to solve, which will be very easy. You start with the RHS. Now, angle PBA is an exterior angle for triangle ABC. So it will be equal to 2y plus x. So this is 2y plus x. And angle PAB is x. So if I subtract it, it's coming as 2y plus x minus x, which is 2y. And half of 2y is y. And CAD is also y. Hence prove that LHS is equal to RHS. So when you come across such sums in exam, how will it strike you how to go ahead, from where to start, which theorem to use? That requires a lot of practice. A lot. There is no shortcut. You have to do it. Here are the steps of the 12th sum. Oops. And finally the 14.2 sum. 14.1 you had already solved in the previous video. Note that 13th and 15th are for homework. Make sure you spend time in understanding the sum and solving it. Don't give up. Now 14.2 is pretty easy. It's given that AD is equal to DB, but they have asked us to prove that AE is equal to BC. First of all, we know that if chords intersect internally, then AD into DE is equal to BD into DC. But out of that, AD and BD are equal. That means DE and DC are also, AD and BD are equal. So DE and DC are also equal. And if you add them, you prove that AE is equal to BC.